This is an exciting day in our department. It's always exciting when one of our students gets to the point where they're defending their thesis, their original research they've conducted here at Ball State. So today we have Anthony Phillips. He's been here, this is his second year, and he received his undergraduate degree from Virginia Tech. And his long-term plans actually going back there.
4 more years.
4 more years. So you can't get enough of this type of mind. Anyway, he's done some research on flash flooding in southern Appalachians. He's doing a brief presentation on that. Then afterwards, there'll be a chance for all of you to ask him some questions, and then we'll actually send you on your way with the video asking some questions, and we will meet with him to discuss what changes we'd like him to do to his thesis research. Go ahead, Anthony.
Does everybody see? All right. All right. Okay, well, good afternoon. I want to thank everybody again for coming out this afternoon and stopping by. So hopefully this will be a pretty interesting presentation. If it's not, I'm sorry. So I know I offer extra credit to most of my students for that. All right, so just an outline of what I'll be talking about this afternoon. I'll give a brief introduction, talk about what is flash flooding, and I'll talk about some of the previous research that was conducted over the past several decades on flash flooding across the nation and across the region. Then I'll talk about my research and how it goes beyond the previous research that others have done, and I'll talk about my data and methodology, as well as my results, some statistical analyses, and some climatological analyses. And I'll end with a brief summary and some question and answer session. So what defines a flash flood? There are several definitions. The World Meteorological Organization uses one definition. The National Weather Service here in the United States uses another. The NWS one is much more detailed and much more complex, but they define a flash flood as within 6 hours, or often within a single hour, of an event such as an intense rainfall, a dam break, or an ice jam formation. One of the following occurs. And the three first one here are the ones to concentrate on, because those are what usually happens. Is a river or a stream will actually flow out of its banks, threaten life and property. You'll get a person that gets swept away, or a vehicle that gets swept downstream due to flood waters, or just in general, county or state road will actually get inundated. The residents of the southern Appalachians are a little bit greater risk of flash floods due to several factors. One is the steep, complex terrain of the region, and that combined with the rapid accumulation of precipitation in these small stream basins leads to quick hydrologic response. Well, people are in competition with these small streams in these hollows and mountain valleys. Their lives are in danger whenever any type of heavy precipitation event unfolds, because they live so close to these streams that can overflood or overfill and then flood. There's also the threat for mountaintop removal, and that's a process of strip mining where the overburden is actually pushed down into these smaller streams, backs up the rivers and backs up to the streams, and then that causes a problem if there's a dam break or levee failure, flash flooding downstream. So I want to show a quick video here of a flash flood that recently occurred. This was just a couple weeks ago. This was in Logan County, West Virginia, and it happened around 9 o'clock in the morning. So a little bit unusual early in the morning, but I'll get on to that here in a minute. But it was filmed at a local community college when students had just got on campus and they were having classes. So we'll go ahead and watch that. So if you're not familiar with, most of you probably aren't, but Logan County is just southwest of Charleston, which is here. It's actually right in this area. This is a Google flyby. It shows the terrain really well. This is Logan County here. And it'll zoom in here and it'll show the actual community college, which is right here. And the stream actually flows underground. There's some culverts right between the buildings. And it's all of this runoff that causes the flash flood from this drainage basin. And you notice there's a lot of homes, and this is common across the southern Appalachians. People live really close to the streams in these hollows, and then when you get a heavy precipitation event, then you get flash flooding. So this is what happened at that time, day in that particular basin. So this is a road, and then there's a stream that goes under the culvert underground here, but you can see the culvert wasn't big enough. And it's flowing down to this parking lot.
It's lots like here, one to the library that belongs to. Yeah. Where they occur, there's lots of cars.
So water has a great force, especially since, you know, a cubic foot of water weighs about 62 pounds or so, 62.4. So it's pretty powerful. This is just the other perspective. They'll actually go in the building and everything here in a second. But same place, community college. And then this is the main street right here. So this is a mud court that actually overflowed. This was a brand new community college. They just built this last year, and sure enough, just a couple weeks ago, flooded.
Was this the first time this ever happened in this area?
No, this happens a lot. But the one woman that was interviewed says she doesn't remember it being this bad in 20 years.
I don't look everything. That's already taken care of. I have no idea. No.
This guy, he actually gets up there, so he's fishing for something, I don't know what. Just another perspective, it's probably a really mountainous area. This community college is right at the base of the mountain hollow. So people couldn't go anywhere, they were stuck where they were for several hours. Couldn't do anything. Don't ask me what he's trying to catch, but. So just a little bit more information about 300 to 400 homes were damaged or destroyed. They did get a federal directive for disaster issued, and there were some trailers that were overturned. 3 inches of rain fell in a 2-hour period, so that's how much rainfall they got. I believe the total rainfall was about 4.5 inches within about a 6-hour period. So several students were trapped in schools. They couldn't move buses, couldn't get anybody home or anything for several hours. And of course, schools and stuff was closed the next day while they cleaned up. But that just goes to show how flash flooding affects residents in the southern Appalachians. And it's a real danger. It happens all the time. Like I said, this happened just a couple weeks ago. So So now we'll move forward and talk about some of the previous research that's been done both in the southern Appalachians and across the United States. There's been several climatologies developed, but they've all defined flash flooding differently, and they've all used different spatial and temporal scales. The three I focus my research on, and what I'll talk about this afternoon, is Maddox, Gaffin and Holtz, and Stonefield and Jackson. So Maddox and his team examined 151 flash floods that occurred between 1973 and 1977. They looked at flash floods across the entire United States, not just the Appalachian region. And they also examined the mesoscale and synoptic scale situations that were prone or that occurred during these flash flood events. At this time, though, there was no specific definition of what constituted a flash flood. So they were just going off of, what they thought was considered a flash flood in the storm database. But they also didn't have a database to go to directly. We have that now with the National Climatic Data Center storm data database online that anybody can access. But they had to actually go back and dig through records and look through the stuff to find references to flash flood events during between 73 and 77. But they came up with some interesting results and stuff that's still valid today. They found that 86% of flash floods occur during the warm season, which is April through September. 25% occur during the month of July. They also found that a large percentage of flash floods occur between 0600 and 1800 local time. And then these are a few of the things that we still look for in forecasting and analyzing flash flood events today. And this is stuff that they discovered, that heavy rains were usually brought about by convective storm systems. You also have to have high dew point temperatures at the surface, as well as abundant moisture throughout the atmosphere. And usually these convective storms would keep training over the entire region over and over. So a storm would develop, move on, and then another storm would develop right behind it and add to the total precipitation. So that was their research. Gaffin and Holtz in 2000, they examined over a 39-year period of flash flooding between 1960 and 1998. But their climatology, even though it was more climatology in the sense that it was more than 30 years data, it was only limited to the Morristown, Tennessee county warning area. So that's in the eastern part of the state of Tennessee. But they did utilize information from storm data, and they also looked at synoptic patterns associated with these events. They did exempt the research from urban flooding, which is defined differently from flash flooding, but they're very closely related. They also divided multi-county events, flash flooding, into single events per county, which we kept, in my research, I kept that same basis. Some of the research that they found that a large percentage of flash floods occur across counties with higher population densities. So as we expect, population increases, urban areas increase, then there's more flash flooding. But they found that this was a result of urban development along these smaller stream basins in their county warning area. Also, counties with higher elevation, usually the counties that have the most destructive flash flood events. So especially into Scott and Wise County in southwest Virginia, and along the Great Smoky Mountains in eastern Tennessee and western North Carolina. So just like Maddox and his team, Gaffin and Holtz also found that the month of July had the most flash floods, and that was followed by March and May. But there was also a significant decrease in flash flood events during fall, so October, November, that time frame. They also, again, found that flash floods occur during the afternoon and evening hours. And then finally, the third climatology I'm focusing on is the climatology from Stonefield and Jackson. I know these two guys personally from Blacksburg forecast office when I interned a couple years ago. there. They was actually developing this while I was there. And it's very similar to Gaffin and Holtz's research. They used data from storm data, but they added to the research by developing a flash flood classification system that deals with severity of these events, and it's the Flood Severity Index, or FSI. And it's based on the monetary damage that each of these events incurs. It's a 5-scale system from FS1 to FS5, so an FS1 event is going to be a nuisance event. FS5 is going to be a catastrophic event where several $1 million worth of damage is incurred. Some of their results, they analyzed 766 flash flood events over the county distribution of Blacksburg Forecast Office, as well as several annual and monthly climatologies were derived. They also found that most flash floods occur during the warm season. A large percent occur during the afternoon and overnight hours between 1200 and 2100 local time. And 83% of flash floods were categorized as either minor or nuisance events. So, not much damage associated with these events. They also identified a couple areas shown in this map where flash flooding is more common across the Blacksburg area. One is along the Appalachian Plateau, and the other is across the Blue Ridge near Roanoke, Virginia. So what I wanted to do with my research is I wanted to take it a little bit further and do some more analysis in ArcGIS, and I wanted to create a climatology across the entire southern Appalachians using verified storm reports from storm data. Also wanted to look at the spatial and the temporal extent of flash flooding across the region, as well as analyze the geographic and the topographical influences and how population and social characteristics affect flash flood reports. And also talked with local forecast offices and meteorologists and got their consensus and their intake about where they think flash floods are bound to happen across their area, as well as some of the meteorological conditions that they always associate with these events. So I defined the southern Appalachians as those mountainous areas south of the Mason-Dixon line. So that's around 39.7 degrees north latitude. And it had to be locations within one of the 3 USGS geographic or physiographic divisions or provinces. Either was the Appalachian Plateau, Valley Ridge, or the Blue Ridge. So I dug around and got the storm data from the NCDC, which goes back to 1950, but I wanted to focus on events after the modernization and associated restructuring of the National Weather Service in the mid-1990s. The reason for that is, after the MAR occurred, storm reports had to be verified. So meteorologists and warning coordination meteorologists at the weather offices had to get on the phone, call up people in the affected areas and ask them if this actually occurred. So they knew if the event occurred and they could get accurate data. The events prior to the MAR, so anything before 1995 or so, reports could be sketchy, so I didn't want to include those in my data. So this resulted in an abbreviated climatology from 1996 to 2010. So we're talking 15 years. So it's not a full climatology in the sense it's a 30-year or 50-year climatology, so I'm limited on some of the data, but it does represent flash flooding fairly accurately, as you'll see here in a few minutes. So this was my study area. Again, here's your 3 provinces that USGS defined. So any county that was within these provinces or that was adjacent to one of them was included in my study. I took all of the storm data flash flood reports, put them into ArcGIS, and plotted their latitude and longitude points. So that gave me where the events occurred within ArcGIS. So then, using other things like average slope for each county, some other stuff, I could actually do some analyses. And here's just a few of the things that I looked at. Number of events per county, which I'll talk about here in a minute. Looked at injuries, fatalities per county, Also looked at some statistical stuff in ArcGIS, such as hotspot analysis, cluster and outlier analysis, and point density. So these are the flash flood events per county between 1996 and 2010. Again, you can see that the darker colors here, around these larger cities, so Roanoke, Virginia, Huntsville, and Birmingham, Alabama, they all have a lot more flash flood reports. But then there's also a few events that are, a few counties that had a great number of events in eastern Kentucky and southern West Virginia. So looking at these flash flood events on a point density map, again, you can still see eastern Kentucky and then southwest Virginia and parts of Alabama had the most flash flood reports. Originally, I thought that those counties with a higher frequency of flash flooding would be directly correlated with counties that had higher mean percent slopes. So, as the topography gets higher and then the slope increases, there'd be more flash floods. But just looking at that data compared to the number of events per county, it doesn't appear to be the case. That doesn't mean, though, that topography doesn't play a role in flash flooding. It does. But just looking at slope versus the number of events across the county, there isn't much of any correlation between the two. However, I did look and find that if we compare the number of flash flood events per square kilometer to the number of people or residents per square kilometer, that there was a correlation between these. So this was either the result that there were more people to actually witness the flash flood and report it, or there were just more urbanized areas and actually flash floods occur because it's an urban area. From talking with the people at the Weather Service offices across the region, it's most likely due to the urban landscape. But taking into account population, I created a normalized distribution of flash floods. And with this, the results changed a little bit. The Virginia highlands have the most flash flood reports, and also areas across eastern Kentucky and then down to Alabama. Looking at some statistical analyses in ARC, this is hotspot analysis. It too shows that there's more flash flood events or more flash flood reports across the highlands, the Virginia highlands, and also eastern Kentucky. But then there's fewer reports across eastern Tennessee and northern Georgia. Some other climatological results. This is frequency of events per year. So 2003 had the most flash floods. That's followed by 1996. And there was a noticeable variation between the years that had drought versus the years that didn't have any drought. So this was, drought years was 1999, and then also in 2007, and then 2003 was a non-drought year when we had the most flash flood reports. Number of events per month. My research is a little bit different than past climatologies. June was the month that had the most flash floods, followed by May and then July. But about 75% or 3/4 of the flash floods occurred during the warm season, which was between April and September. There was a dramatic decrease in October. Only like 30 or so reports of flash flooding across this entire 15-year time span. So October doesn't have that many flash floods across the southern Appalachians. So this shows the spatial distribution of flash floods across the region. So as you notice, if you start from January, work your way to December, each month that flash floods there's a higher frequency of flash floods on the western side of the Appalachians during the spring months, and then that transitions more to the eastern side of the Appalachians as you get through summer, and then eventually, when fall rolls around, most of the flash floods are confined to the leeward side of the Appalachians, where tropical systems will come up from the Gulf and provide necessary rain for flash flooding. The events per time of day, I looked at this as well. Again, just like the previous research, I found that most flash floods occur during the afternoon and evening hours, but there's also a small spike around 9 a.m. That's above the median value. Just like the flash flood that occurred a couple weeks ago in Logan County, it's most likely because of MCSs that develop on plains and then they move into the Appalachians. Right about this time frame is when they actually move into the Appalachians and produce flash flooding. Looking at the number of events per day compared with the events per hour, so this shows the day along the x-axis and then the time that the event occurred along the y. There's a large clustering of flash floods, again, between the afternoon and evening hours, but also between April and September. And if we compare that to the catastrophic and the major and significant flash floods, so FS3 to FS5 events, most, again, occur during the afternoon and evening hours, but significant flash floods last longer, so there's a continuation into the overnight time frame as well, but most occur during the time between April and September. And of course, there's not many during the month of October. Another animated GIF image here. This shows flash floods that are ranked for each of the 5 FSI categories. So as you can see, West Virginia doesn't have many nuisance events, but they do have a lot of the severe weather or severe flash floods, the FS3 to FS5 events. So that's plotted here. Most of West Virginia, southern Ohio, and eastern Kentucky, but also Birmingham, Alabama, they get a lot of significant flash flood events to occur in that area because of the urban nature of the landscape. I looked at the fatalities and injuries associated with flash floods, and I won't get into those particulars, but I want to go a little bit further and examine how these deaths occurred. And what I came up with was quite the opposite of what the national average is. Most fatalities in the U.S. occur in vehicles. Well, the fatalities across the southern Appalachians occur when people are either out walking or they're on foot. A lot of the reports I looked at were a lot of young children and even young adults that would actually get out into these swollen creeks and streams, get swept off their feet and downstream and drown. Also students, that were getting home off of from school, they have to walk up these roads and these hollows. They stop and look at the floodwaters and then get in trouble, actually drowning in these events. And then finally, I talked with local weather services offices to verify my study, and they gave me some similarities and some differences with my study compared to what they found, but mostly a lot of similarities with what they've seen compared to what I found in my climatology. But usually flash floods occur with greater frequency over the urbanized areas. That's what they found. I also found the same thing. June is usually the typical month for flash flooding, and most flash floods are nuisance or minor events, with the significant and the most damaging events usually occur across the rural areas. So in summary, there were 4,938 unique flash flood events to occur across the southern Appalachians between 1996 and 2010. Of those, there were 71 fatalities and 64 injuries. As expected, there was a greater number of flash flood events during the afternoon and evening hours and during the warm season months. So that's just in line with what previous research has found. There was a correlation between the number of events per square kilometer and the population per square kilometer. And we found the probability of a flash flood occurring within a 25 square mile radius or 25 square mile area is around 36% each year in the southern Appalachians. So future work should include looking and expanding this research to include the eastern U.S. and also analyzing some of the atmospheric conditions, meteorological conditions that are associated with flash floods. So I would like to thank my committee Dr. Call, my advisor, and then my two committee members, Dr. Coleman, Dr. Zimmerman, as well as Stuart Henson out of the NCDC in Asheville. He provided me with this data and some insight into some stuff, as well as the weather forecast offices across the region, and also the faculty here in the department. They've been very supportive over the past couple of years. I've enjoyed it quite a lot. Appreciate everything. And of course, colleagues and grad students, they're a great bunch to be around, and a lot of fun times. So appreciate their help and support as well. So are there any questions or general comments?
Thanks very much. We are running on a tight schedule today, so we'll just field a few questions. Questions for Anthony from the audience?
If I understood you right, you geocoded something like 4,000 discrete flooding events, right? And so you had that map where you had all the events as points distributed. I would dream of asking you to revise anything, so I'm not anything, but for future work, if you were to take this down the road, one of the things that you've done is by geocoding events in that way, you have the opportunity to step over possibly a problem in some of your analyses, which has to do with the modifiable aerial unit problem. And that is, you have irregularly sized, shaped, and connected aerial units that you aggregate your events into for your analysis.
Right.
Count by number of counties, right? Because you've got disaggregated point data there, you can create uniform standard units of analyses that you can then use to re-aggregate information at whatever scale and size that you wish to do.
Okay.
In other words, you can grid that whole area,
Right.
and you're not locked into counties as the boundaries for your units of analysis.
Now, I've done that with my Poisson distribution, because that's how you get it. So I had these 25 square mile cells, and I just calculated the distribution across those cells.
When you make those moves, you have to be prepared to defend.
Why I chose.
Uh-huh.
Yep.
But-
So I did do several different ones,
Okay.
and they come out similar, but as you increase the size of those cells, the chance of a flash flood is going to increase. So,
And did you share your G-star analyses here?
I don't think I did in this, but I did. It's in my.
Any clustering based on those sort of units of analysis would be something to think hard about.
Yeah. Anything else? No? Yeah.
Anthony, early on I noticed that Birmingham had lots of flash floods. And I immediately looked for other cities, Richmond, well, it's not in that portion, but Knoxville, Asheville. What is, I think I understand why impervious surfaces engender flash flooding.
Yes.
But what is it about, it's not urban geomorphology, what would you call it?
Urban morphology. Just call it urban morphology.
Yeah, but I think of shapes of cities as urban morphology. One would think that with the construction of culverts and everything else, that flash flooding would be less of a problem.
You would think.
Despite the impervious surface.
Right.
Yeah.
But it's just not the case.
Yeah.
It's because people are in such a small area, that results in, more fatalities and stuff too. I found that in Charleston, West Virginia. Of course, the terrain's influenced, but Charleston's an urban area. There's a lot of fatalities in that county. But the urban landscape is just so, there's nowhere for that water to go, except for in these storm drains, and they're just not big enough.
They're not sufficiently large.
Is that a question or a comment, or hopefully
The query.
With the FS scale, it assesses the monetary value of damage, right? Do you think with future research, you could come up with a metric that perhaps could assess the actual impact or severity of the rushing water and mud itself, and like an EF scale of tornadoes?
Well-
regardless of population? Because, you know, population and settlement will change through time.
We're actually in the process of doing that, and that's what I'm going back to Virginia Tech for, is I'm going to be studying flash floods, and we're going to be looking at how the Weather Service identifies those places that are most prone to flash flood events. And it's based on several factors like land use, soil type, things like that. But as for, you know, a specific, you know, if this stream's flowing faster, you know,
Yeah, exactly.
I don't,
It'll
it'll be kind of that route, but it's still a long way, let's say, from getting something like that.
Okay, thanks again, Anthony.